Hello! In this video, we'll look at instructions used in assembly language programming. So, suppose we had a simple program like a equals b plus c, and we want to write that in assembly language. In RISC-V, we would write it as add a comma b comma c, or you might also read it add a gets b plus c. The add is called the mnemonic. That indicates which instruction to perform. And the instruction takes through two sources and a destination. The destination is A, that's where the answer is put, and the two sources are B and C. Subtraction is similar, only the mnemonic changes. So if we wanted to do A equals B minus C, we could write it with the instruction subtract, A gets B minus C. Again, the mnemonic now is subtract, and the operands are the same, destination is A, and the two sources are B and C. Design principle 1 is that simplicity favors regularity. So notice that the instruction format is consistent. Both add and subtract have the same number of operands, two sources and a destination, and they only differ in the mnemonic. This makes it easier to encode the instructions and handle them in hardware. Suppose we wanted to write a slightly more complicated program, a equals b plus c minus d. You could imagine an architecture that had an instruction that did all this in once, but in RISC-V instead we break it into two steps. We'll add t gets b plus c, and then we'll subtract a gets t minus d, which will give us the b plus c minus d. So we've introduced a temporary register t and a sequence of two instructions to run the program. This leads us to another design principle of making the common case fast. So RISC-V only includes simple, commonly used instructions. As a result, the hardware to decode and execute these instructions can be made simple, fast, and small. And we'll look at that in Chapter 7. So if you want to perform more complex instructions that are less common, we break them into a sequence of multiple simpler instructions. So RISC-V is a great example of a reduced instruction set computer with a small number of simple instructions, and it stands in contrast to other architectures like Intel's x86 architecture that are complex instruction set computers with a vast number of different instructions, including things like a single instruction that copies an entire string from one memory location to another.